we're going to do lesson 92 boat in the river problems. If you don't like distance problems, it's okay because these are a lot easier than our normal distance problems. We're going to do boats in a river, and there's going to be two equations that we're going to use, and it's fairly easy. We remember that distance equals rate times time. We're going to have a boat going downstream and then the boat coming back upstream. This is the equation we're going to use. The distance equals the rate, and the rate isn't just going to be one number, it's going to be two. It's going to be the rate of the boat in the water, like the boat has a motor on it and has a speed, but it also is the water, which is a current that pushes the boat and increases its speed if it's going downstream. The water is going to increase the speed of the boat. On the other hand, if a boat's going upstream, we're going to have the distance upstream is the rate, which is now the boat speed, minus the water speed, and that's going to be the rate. So we have two numbers for the rate now, and then it's going to be times the time upstream. So let's look at example one of these problems. Rob and Clay could go 60 miles downstream, and so that's going to be our distance downstream. So all you have to do is identify what each of your variables are here. We could have a distance downstream, the boat speed, the water speed, and the time. So those are the things you're going to be looking for as you read your problem. So we have 60 miles downstream in the same time. The time's going to be the same, so just keep that in mind, that it took them to go 20 miles upstream. That's your distance upstream. If the speed of the boat, and that's B, it's going to be the same B, the boat's going the same speed itself, upstream and downstream. In Stillwater, is 8 miles per hour in Stillwater, what is the speed of the current? And that's going to be W, or speed of the current, our water. And what were their times? Every time you do one of these problems, you're going to copy down this equation. And I'm going to rewrite it here, just because the book does it this way. So we have, I'm just rewriting these equations down here, and we're going to fill in the numbers. So it's pretty simple. If we have the speed of the boat, which is 8, so where the B is, we're going to put an 8. We don't know the current of the water, that's what we're looking for. The time, it's the same in both going upstream and downstream, so we can just put T. And the distance downstream is 60. So these are actually really simple because you don't have to think much, you just have to plug the numbers in. The boat speed is 8, minus the current we don't know. The time upstream is 20. Oops, the time upstream is T. It's the same as the one downstream, so we're just going to use a T, equals 20. So now we have two equations with two unknowns, and we just need to solve them simultaneously using elimination. So I'm going to distribute the T, so we're going to get 8T plus TW equals 60. And I'm going to distribute the T here, and I'm just going to put it right under so we can go right to elimination, is 8T minus TW equals 20. So just distributed, line them up, and this one works out real easily because they eliminate quickly. So we get 16T equals 80, and we're going to get the time equals 5 hours. Once you get the time, then we can go back and find the current. They're the two things that we're looking for. So we're just going to put our 5 in up here where the T is, in both places. So we're going to get 8 times 5 plus 5 times W equals 60. And we're going to get 5W equals 20, if I subtract the 40 from the 60. And the water speed is 4 miles per hour. So they're very straightforward, each kind's a little bit different. You can stop. All right, example 2. This time we're going to know some different pieces of information, but we're going to use the same equations. We have our downstream equation with the plus the water, and the upstream equation with the minus the water. So this problem is the steamboat Judy could go 70 miles per hour 70 miles downstream in 5 hours. So our distance downstream is 5 hours, is 70 miles. Our time downstream is 5 hours. But required 6 hours to go 48 miles upstream. What was the speed of the boat in still water? So we want to know the speed of the boat, which is our B, is what we want to find out. And what was the speed of the current? So we're going to find out B and W, so that means we don't know B and W to start. But we do know the time and the distances. So we're going to fill in our time downstream, our distance downstream, our time upstream, our distance upstream. These are pretty straightforward. You just plug them right in. So we don't know our B and W, so we just say B plus W. We're working on our downstream. So we need our time, and it says 5 hours, so we just put a 5 there. And our distance is 70. Then we do our upstream. We don't know our B and our W, so we leave them in. Our time upstream is 6, and our distance upstream is 48. So those are two equations. Now we just need to distribute and use elimination. So we get 5B plus 5W equals 70, and 6B minus 6W equals 48. This one's a little bit more complicated elimination. We'll take this equation by 6 and this equation by 5 so that we can eliminate the W's. So we'll get 30B plus 30W equals 420. 30B minus 30W equals 240. Now we just add those together, and we get 60B equals 660, and divide by 60, and we get B equals 11. And we're talking about boat speed, so it would be, and we're talking miles per hour. Now we have to go back up. We'll go up to this equation, and we'll find our water speed. So we just put our 11 in for our boat speed. So we have 5 times 11 plus 5W equals 70. 5W equals 55 minus 70. Did I do that right? Equals 15. And we get W equals 3 miles per hour. Just check that. 5. So we have our two speeds. Okay, our final problem is example 3. Okay, example 3 is a little bit different, so pay attention. The water in Flint River flows at 5 kilometers per hour. So this time we're going to know the speed of the water, not the speed of the boat. A speedboat can go 15 kilometers upstream in the same time that it takes it to go 25 kilometers downstream. Look, note the same time. That means we're going to just use the generic T. That it takes to go 25 kilometers downstream. How fast can the boat go in still water? So we're looking for the speed of the boat, so we're looking for the B. This one's tricky because they're starting with the upstream. So we're going to put the numbers in this equation first. So we have the boat, the speed of the water is 5. The time we're just going to make T because they're both the same. We don't need to subscript them. And the distance is 15. This one's the same thing. Boat plus 5. The time is just T, and this distance is 25. Now we're going to distribute and solve simultaneously. So we're going to get BT plus 5T equals 25. BT minus 5T equals 15. Now here's the tricky part. We have these 5T and minus 5T, and it would be simple just to think we could eliminate it and just get 2 BTs, but what are we going to do with the BT? So we want to eliminate the BTs by multiplying the second equation by minus 1. So we'll get BT plus 5T equals 25 minus BT plus 5T equals minus 15. Solve. We're going to eliminate the BTs, which are useless variables, and we get 10T equals 10, and the time, we found out the time first. They don't even want to know that, but we need to find the time in order to find the speed of the boat. So we're going to get the time is 1 hour. We in hours. Now we have to take this 1 hour and we have to put it back into the equation for T in order to get the B, the boat speed. So we're going to get B plus 5 times 1 is 5 equals 25, and we're going to get the boat speed equals 20 kilometers per hour.